Most people still think AI agents just write code. They imagine Copilot finishing a function or cursor suggesting a fix. But here's what most people don't realize. Today's AI agents can browse the web like a human. Control your desktop. Run your entire server infrastructure. Research complex topics like a PhD student. And collaborate with each other in teams. All autonomously. And they all run on one universal pattern. Think. Act. Observe. Repeat. Let me show you where agents are in 2025, beyond code. In 2022, researchers dropped something called ReAct. Reasoning plus acting. It seems obvious in hindsight. But before ReAct, models could either think step by step or use tools. Never both at the same time. ReAct changed that. The model thinks, then acts, then observes the result, then thinks again. It's a loop. And every modern agent, ChatGPT plugins, Claude with tools, Hermes agent, all of them run some version of this loop. Anthropic published a guide last year that drew an important line. Workflows follow predefined paths. Agents dynamically direct their own process. Their advice? Start simple. Don't reach for a framework until you actually need one. For the local LLM crowd, there's a catch. Smaller models struggle with multi-step reasoning. Tool calling fine-tuning helps. A lot. But context windows fill up fast. Each think-act-observe cycle burns tokens. That's the bottleneck. Let's get practical. Browser agents let an AI navigate real websites. Not by scraping HTML that breaks on modern JavaScript, shadow DOM, iframes. Instead, they take screenshots and decide what to click. Same way you browse. WebVoyager pioneered this in 2024. The LLM looks at a screenshot of the page, chooses an action, click, type, scroll, and Playwright executes it in a real browser. Then another screenshot. Then another action. The agent sees exactly what you'd see. There's an open source tool called Browser Use that brings this to local models. And CogAgent is an 18 billion parameter model purpose-built for GUI understanding. It runs on consumer hardware. The takeaway? Your AI can browse the web. And it doesn't need your APIs to do it. Google Deep Research launched in December 2024. You give it a question. It creates a research plan. Then it searches, extracts, cross-references, identifies gaps, and searches again. All on its own. When it's done, you get a full report with citations. OpenAI's version came 2 months later. Same approach, plus PDF reading and image analysis. The architecture flows like this. A planner creates the search strategy. Then a loop kicks off, search, extract, verify, spot gaps, search again. Finally, a synthesizer cross-references everything and generates the report. For local users, this is viable. RAG over your own papers works. Web search via APIs works. But smaller models tend to echo the first source they find. Genuine multi-source synthesis? That's still hard. This one's wild. Anthropic's computer use tool, still in beta, lets Claude control your actual operating system. Mouse. Keyboard. Scroll. Multi-monitor. Everything. Here's the mechanism. Claude takes a screenshot of your desktop. Analyzes the pixels. Decides what to do. Then outputs coordinate-based actions. Move mouse to 847, 533. Left click. Type this text. Those actions execute on your real OS. No virtual environment needed. This is fundamentally different from browser agents. Browser agents work inside the browser ecosystem. Computer use agents work with any software. Terminal. VS Code. Slack. Photoshop. No API needed. No accessibility tree. Just pixels. For local LLMs though, this is the toughest category. You need strong vision language models. Latency is punishing on consumer hardware. For now, it's more practical for offline batch automation than real-time use. But the direction is unmistakable. DevOps agents are probably the most practical category for local LLM users right now. The pattern is simple. Alert. Diagnose. Act. Verify. An agent monitors your logs, spots an anomaly, identifies the root cause, runs a remediation script, and checks it worked. If it didn't, it escalates to a human. Tools like K8 SGPT scan Kubernetes clusters and explain issues in plain English. Self-healing infrastructure handles autoscaling, certificate renewal, disk space all automatically. This works well with smaller models because the loop is more straightforward. Detect a specific condition. Run a specific script. Large context windows help with log analysis. And since you're running locally, there's zero API cost per cycle. What happens when you put multiple AIs in a room and tell them to cooperate? The orchestrator worker pattern is the most common. One central LLM plans the task and delegates to specialist workers. A coder. A researcher. A data analyst. Then it synthesizes the results. Then there's the debate pattern. Multiple agents critique each other's outputs. This actually improves factuality, even with smaller models. Having two AIs disagree beats one AI being confident and wrong. Here's the surprising part. Multi-agent is viable on local hardware. You can run 3 or 4 smaller models in parallel on a single GPU. A 7 billion parameter orchestrator. 3 billion parameter workers. But watch for the anti-patterns. Token costs explode. Context gets fragmented between handoffs. And agents can form echo chambers, reinforcing each other's bad assumptions until nobody catches the mistake. Let's ground this with real numbers. Web Arena is the gold standard. It's a self-hosted environment with fully functional websites, e-commerce, forums, GitLab, content management. 812 real-world tasks. Published at NeurIPS as an oral paper. GPT-4 achieves 14.41% end-to-end success. Humans? 78.24%. That 64-point gap is the clearest measure of where agents actually stand in 2025. Impressive demos, brutal benchmarks. Open models trail closed ones by 30 to 50%. But fine-tuned Qwen 2.5-72b and Llama 3-70b are closing the gap fast. Other benchmarks worth knowing. GAIA for general reasoning. SWE Bench for coding. OS World for desktop automation. And the Agent Company for workplace tasks. Progress is real. But we are nowhere near done. Here's the uncomfortable truth. Agents have access. Tool access means your agent can delete files, spend money, send emails, or execute arbitrary code. Sandboxing is not optional. Best practices are straightforward. Run agents in Docker containers. Use dedicated API keys with quota limits. Add human approval gates for destructive actions. Set hard timeouts. There's also a threat unique to agents. Indirect prompt injection. Imagine your agent reads a web page with hidden instructions embedded in the content. That page can now steer your agent's behavior without you knowing. The upside for local LLM users? Your data never leaves your hardware. That's a genuine privacy advantage. But smaller models have weaker refusal guardrails. So sandboxing matters even more, not less. Let me put this progression in perspective. 2022 was tools. Simple function calling. 2023 was workflows, multi-step orchestration with predefined paths. 2024 was the breakout year for agents, dynamic, model-directed processes. And 2024 into 2025 is the era of specialist teammates. Role-specific agents collaborating together. What's real today? Browser agents. Research agents. Coding agents. DevOps agents. Computer use in beta. Multi-agent frameworks you can run tonight. What's still hard? Long-term memory. Cross-domain skill transfer. Hallucination in long trajectories. And cost agent loops burn tokens fast, even locally. The gap between open and closed models is narrowing, but it's still there. 2025 is the year agents become genuinely practical for local users.